Hello people, in this video in hearing aid, we are trying to look at implantable hearing aid. So this is also called as vibrant sound bridge. One of the examples is actually vibrant sound bridge. So you should know this one. It is coming under implantable hearing aid. Remember, it's a hearing aid. Okay, don't get confused with this word implant, because cochlear implants, auditory brainstem implants come under implants. But here we are talking about implantable hearing aid. Right? Did you get it, guys? So what you see here is a conventional hearing aid. Okay, some people try all these conventional hearing aids and they are not at all happy. Okay, for such people you can try this implantable hearing aid, vibrant sound bridge. This is some different technology, direct drive technology, something they're calling as middle ear. Directly they will take the sound. Wait, better see here. See, this is your middle ear ossicle. See, it is attached to the incus. Some floating mass transducer is attached to the incus. This is one of the positions it can attach. There are many other options. Anyways, then here they are taking an audio processor which will have a microphone which will catch all the signals. Right, here you'll have some receiver, then you will have some conductor link, right? Then there is a drum kind of a thing here, floating mass transducer. This will actually vibrate. That time this incus will vibrate, stapes will vibrate, right? Then the sound signal will be sent to the brain, correct? So these people will hear in a very different way. Don't put a hearing aid here. Don't give a bone conduction kind of a thing. Directly you're taking information and giving it to the middle ear. Okay, so this is what is vibrant sound bridge. Remember, everything here vibrant. It's going to vibrate, right? So it is an implant where in the middle ear it has some direct drive principle. So it will take all this sound energy, convert it into electric, convert it into mechanical. Mechanical vibrations will be directly delivered to the ossicular chain. So the ear canal will be open for these people. So basically, there are two types in this, guys. Piezoelectric devices and electromagnetic hearing devices. Okay. So mainly here we will be looking at this one, electromagnetic hearing devices. Example, you have this vibrant sound bridge. Focus, guys. What are the two options? Piezoelectric and electromagnetic. Very good. In that we have the vibrant sound bridge device. So earlier it was known as Symphonics device. Now it is being manufactured as Medel. This Medel people in YouTube, they have a lot of videos. Okay, you can look at that because they are the manufacturers. They have made some videos. See, look at this one here. So here they are showing you how the signals are coming, and here you have this floating mass transducer, like a drum it's sitting here on the incus, right? So it will vibrate. Okay. So let us look at how it works. What do you see here? Vibrant Medel sound bridge. So you can see that here they have zoomed it and shown here the textbook. Implant which is in position. So here you can see the implant in position. B is external audio processor worn on head. So here you can see external audio processor which is worn on the head. Inside also you have something, guys. Inside like this, something you have. What is that? Internal implantable floating mass transducer. Okay. So this is from Medel Corporation. Those people. Looks like the textbook also mentions its name. Okay. Guys, see this? This vibrant sound bridge is semi-implantable device. It has two components, internal and external. External, what will be there? Audio processor will be there, which will have a microphone that you know. Then internal, you have this vibrating ossicular prosthesis. So whatever is there inside, only that is called as VORP, vibrating ossicular prosthesis, right? And that will be made up of three parts: the receiver, conductor link, and the floating mass transducer. Look at this photo here. So you have a receiver, inside, everything inside, receiver, you have a conductor link and a floating mass transducer. So the conductor link is between this receiver and floating mass transducer. Floating mass transducer, they have shown much more in detail here. This is the floating mass transducer, and here there is a clip that can attach to the incus. Okay, good. So whenever somebody asks you what is the difference between vibrating ossicular prosthesis and vibrating sound bridge device, don't get confused. Vibrating ossicular prosthesis is inside this vibrating sound bridge device itself. And all these are what? Implantable hearing aids. So whom will you give this to? Somebody who's 18 years or older, they are saying. The textbook says this, so you go with this. Interestingly, here you can give it for all types of hearing loss, looks like conductive, mixed, sensory neural. Anyways, that is strange, right? Okay, these people should have tried conventional hearing aids, and they should have expressed their dissatisfaction about the quality, because this one is going to give good quality. Okay, so they will the quality of hearing was not good. They will have some feedback and all that. So this one is a good thing for those people. This will have very good quality of sound, remember. And here you can see that you're not doing anything to the ossicles. Malleus is there in its place, incus is there in its place, stapes is there in its place. You're just attaching a drum here. So the middle ear structures are not modified. There is no significant impact on the residual hearing of the patient. Okay, so all this is important. And you're focusing on what? The quality of the sound, right? So significant impact there is no significant impact on the residual hearing of the patient. So what are the advantages here? Mechanical energy you're directly giving to the ossicles. You're bypassing the ear canal and the tympanic membrane. Both you have bypassed. You'll have improved sound quality. Even in noisy environments, they'll have good quality, okay, of sound, guys. So in this video, what did we look at? Implantable hearing aids. So it's coming under hearing aids. Remember the classification, right? Under hearing aids, you have this implantable hearing aid, vibrant sound bridge, okay. So where are we? Yeah. So basically, it is implanted to middle ear. It's a direct drive principle. Mechanical vibrations are delivered directly to the ossicular chain, right? So you're going to catch the sound signal via the microphone. Then you're going to convert it into electrical signal. Then it is going to convert into, it looks like the transducer will convert it into mechanical energy. It will vibrate and you will pass this vibration. Remember here everything is vibration. So vibrations will be given to the ossicular chain. Here they are saying that whatever hearing loss is there, still the person can hear, which is really strange, right? And the quality of the sound will be very good in this. But this technology you should give to people who have already tried conventional hearing aids, etc. and have not been happy. You have two types of devices here, piezoelectric devices and electromagnetic hearing devices. Under electromagnetic hearing devices, they're talking about this vibrant sound bridge device, okay. So here they are using some electromagnetic, they pass an electric current into a coil, creates a magnetic flux, which drives an adjacent magnet. The small magnet is attached to the ossicles. Oh, they have connected this small magnet to the ossicle. The small magnet is attached to one of the ossicles. Okay, great. So, sound bridge device, you saw that it has two parts. External, it has the audio processor, and internal, it has the vibrating ossicular prosthesis. So, the external part will have a microphone. The internal part will have a receiver and a conductive coil, which will connect it to the fixed, floating mass transducer, FMT, and this is how the floating mass transducer is. And this will have a handle which you can attach to the incus, right? Then you will give it to people who are 18 and above only. They are saying here you will give it to all types of hearing you can give. Dissatisfaction if they've had in sound quality when they are using current hearing aid, which is very conventional. They cannot have good quality, some feedback and all they are getting. Okay, to such people you give. So let's look at the procedure, guys. So what do you think? It's a surgical procedure, right? The internal part and all you have to put. So how will you put the internal one? Surgical under general anesthesia. So where and all you have, what will you place? Under the skin you will place the receiver, right? And how are they doing it? Some mastoidectomy, tympanotomy and all they are doing. Okay, behind the posterior tympanotomy they are doing. So all this they are doing and they are implanting this internal device, okay? And then what they are doing, they are not modifying the middle ear structures. They are just visualizing all this chain and they are attaching the FMT to the long process of incus, okay. And then after 6 to 8 weeks after this procedure, they will fit this person with an audio processor external, which will sit magnetically. Remember, magnetically, it will sit, okay. Then you program the processor. Don't forget to program it, okay. The processor is then programmed. Here one important was there. FMT, you attach it to the long process of incus. Very important point, okay. What are the advantages here? You will direct drive system. See, this is the main thing they're telling here. It's a direct drive. You're driving it directly. You will provide mechanical energy to the ossicles. You will bypass the ear canal. You will bypass the tympanic membrane, everything. Okay. So, a lot of feedback, everything you can avoid. Improved sound quality will be there even in noisy environments. So, that's it. So, we are done with implantable hearing aid, vibrant sound bridge, VORP, etc. Next, we have to look at implants, cochlear implants, etc. We have to look at. That's all for now, guys, in this video. Bye-bye.